Good morning, class. This morning I want to share the topic transformation geometry with you. Then we're looking at the subtopic types of transformation, in which translation is one of the types. Now, for the lesson objective, at the end of the lesson, students should be able to define transformation and give the types of transformation and also solve problems on translation. Now, transformation is just the change in position and the size of an object to give you the image. Now, under types of transformation, we have 6 types of transformations. We have translation, we have rotation, we have reflection, we have enlargement, we have stretch, and also shear. Now, because of the nature of the syllabus, that is IGCSE syllabus, we shall not consider these two. We will not be considering these two, that is stretch and shear. We are not going to talk about these two, but we are going to look at translation, rotation, reflection, and enlargement. But for the course of today, we are only going to consider translation. Now, the definition of translation: an object is translated if it undergoes a straight sliding movement. Let me just give an example. Now, this is a triangle. I can slide this to this point. I can slide to this point. I can slide to this point. I can slide to this point. That's translation. That's a straight movement. So, under transformation, there are 2 things that you have to tell us about if the transformation is translation. The 2 things are, you have to tell us the type of transformation, which is translation. And one other thing you have to mention is the column matrix. So, we'll take this example. Now, make a copy of the diagram below and write down the column vector for each of the following translations. Now, I have the diagram. I have triangle A, triangle B, triangle C, triangle D, triangle F, and lastly triangle E. Now, back to the question. We want to find the translation of the following: D onto A, B onto F. Let's take D onto A first. Now, the translation D onto A simply means there's a connection. There's a link between this. We're going to link up corresponding points. Our movement is from D to A. It's just like a column vector. Moving from D to A. And also, that is this point and this point, they are corresponding points. This point and this point, they are corresponding points. This point and this point, they are corresponding points. So, let me join this and this with color red. Join this with color blue. So, these 3. Now, that's translation. We are translating D to A. So, the black line represents what's corresponding points, the blue line represents corresponding points, the red line represents what's corresponding points. So, what's now the vector? Now, I want to find the column matrix for D onto A. What's the column matrix? Now, the column matrix simply means from this point to this point, how many points are we going to move horizontally and how many points are we going to move vertically? So, let's count. We have 1, 2, 3, 4, 5, 6, 7. Now, since I'm moving to the right, that means that my x is positive, which is 7. Now, don't forget I counted to this point. I counted to this point. I counted 7 to this point. Now, I want to count from here to this point to get my value for y. Now, from this point, I have 1, 2, 3. Now, I'm moving upward. That means that my y is positive. So, I I have y to the positive, which is 3. So that's the column vector for, the column matrix for D translating to A. That's the first one. So let's quickly take the next objective, and then now B onto F. Now this is the diagram. Now we want to take B onto F. Now you join B to F, join this to this. So look at the movement. B onto F. Now, if you look at this, there is no horizontal movement from B to F. So that means that along the x-axis, we have 0, since there is no movement to the right or to the left. Now, if you look at this, now we are moving downward there. B onto F. We are moving downward there. So how many boxes do we have from this point to this point? Or let me just use this space. From this point to this point, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, because we are moving downward, that means that this will be minus 9. So that's the column matrix represents that. So I will enjoy you to go back to the Google Classroom for more of the solutions, for more examples, and the exercise for you to do. Thank you, and God bless you.